Here we go. I can only hope this is going to work. I'm going live. Okay. Okay.
Okay, you're going.
So, good evening, everybody, um, and welcome to a live stream from the San Diego Astronomy Association. The reason I am chuckling here is because we literally were having technical problems until 30 seconds ago. So the confidence in us getting through this stream without too many problems here is going to be interesting. But we'll see what we can do. My name is Gary Hawkins. The presentation or the live stream is we're going to be looking at the constellation of Orion, which is a very famous constellation that most people are familiar with. And we're going to be looking at that through the eyes of Robert Burnham, who wrote a very famous, uh, well, actually, it's a set of three books that we're going to talk about in a few moments. And we're going to look at it through his eyes and use some of his comments. But before we do all of that, I am going to hopefully um, allow my co presenter to introduce himself. Let me switch that light off because that's probably blinding you. And my co-presenter this evening is also from the San Diego Astronomy Association, and that's Dave Decker. Dave, why don't you introduce yourself?
Hi, everybody. It's been quite an evening making sure stuff comes together here at the last minute. I am the outreach coordinator for the Astronomy Association here in San Diego. Is the audio coming through? Okay. So a little explanation. Following the rules for the uh, response to the COVID problem, things have been shut down. We had hoped to do this event and a couple others out at the Ocoasis County Park in the lakeside area east of San Diego. And we did one event there that was wonderful, very easy, and a great setup, a nice place to go. And the park is very, very cooperative. But after the latest changes in the rules regarding the response to COVID, the park advised us that they would not be able to host these events for the time being. So at the last minute, Gary and I have attempted to throw together this program from our homes. And there's been a lot of technical issues, as you may already have seen. We're working through them. I hope you're patient with us. And hopefully, we'll have a chance to share some interesting stuff from Robert Burnham's notes regarding the constellation of Orion. So again, I'm Dave Decker, the outreach coordinator. Gary Hawkins is one of our outreach members who has been a real leader in getting us online to do live viewing. So Gary, are you still there? Are you live?
Yeah, I'm still here. Unfortunately, I forgot when I swapped over to the introduction there to do the transition in OBS. So everybody was still looking at the introduction slide as opposed to um, our
Ah,
our our faces. But I've solved that problem.
ah,
And just to give you an idea of how difficult this is this evening. Normally, we operate at one site. We're together next to each other, or at least socially distanced, and all the computer equipment and everything is in one place. That is not the case this evening. Dave is home in La Mesa. Dave?
yes,
Yeah,
Lisa.
Dave is at his home in La Mesa. I'm actually at my home in Scripps Ranch. Dave is Skype calling into me. I am then taking Dave's Skype stream and blending it into the OBS stream that I'm putting out to YouTube. All my computer is also controlling my mount. And just to make life interesting, this is a new mount that I only purchased about 10 days ago, and it's not being trouble free at the moment. So my mount has crashed twice tonight already. Um, And then just to make it all interesting as well, I have to then send my desktop image back to Dave in real time, because if he views um, the YouTube stream, it's about 10 seconds delayed. And of course, if you're talking about something that's 10 seconds delayed, you get extremely confused. So he's actually seeing my real time feed going back to him. So that's kind of an example of all the pieces that have to hang together here for this to continue to work throughout our presentation. And then the other thing is as well, which is kind of amusing, is that we really plan to do this a little later in the month. And Orion is actually extremely low in the sky for me currently. In fact, it's below my neighbor's rooftop, and um, unable to defy physics. We're actually going to have to take a look at one or two targets, um, sort of on our way down to Orion as it rises above my neighbor's rooftop. So yes, it's all pretty interesting here. So anyway, what I'm going to do now is I'm going to go back to my slide presentation. I'm just going to run through a few slides to give you an introduction of what's going on. I do note some familiar faces on the chat, so I'll just give some calls out to there. Mike over in Death Valley, great to see you. Dave is on board, DJ Reagan, nice to see you as well again. And we've got a few other folks out there as well. So if you have any comments or questions, please let me know. As my audio, oh no, my audio is still going. Thank God for that. I thought my audio had disappeared there. Um,
I think
which,
we're good, Gary.
oh, good. Okay. Well, there's just too much going on here and at the moment. So, right. So my slide deck. Let me start with the slide deck and give you a brief introduction. So, first of all, where am I located? Well, I kind of mentioned that. I'm actually in Scripps Ranch, and I've just realized, of course, that I can't actually use the arrow key to show you where that is on the map that you're now looking at. But if you look, you see the gray area. There's two gray areas. If you go north of the higher gray area, and you go up about halfway, there's a small city called Poway, and I'm located pretty close to the city of Poway, basically in Bortlate skies. So we suffer a lot from light pollution here. And one of the reasons I do EAA is because it's a great way of counteracting light pollution. The camera setup that we're using tonight is a little different to what I've done on live streams, just to add some more interest and spice to whether we can actually keep this live stream going for the entire period. Because not only am I using my regular setup, but I'm also using a guide scope tonight. And the reason I'm using a guide scope is because we're actually going to be doing some longer exposures of some of these targets to pull out some more detail. And because my C8 Schmidt-Cassegrain telescope has a relatively long focal length, even with the focal reducer on it. I need to use guiding in order to keep the telescope pointing at the target so that the target doesn't sort of blur and smear. So I have a guide scope located above my main scope. And behind the main scope, as I mentioned, there's a focal reducer. Behind that, there's a set of filters, and I've got a light pollution filter in at the moment to try and knock down a little bit of the light pollution that we get from the city of San Diego. And then connected to that is a 9 megapixel camera with a square format. And that's all now sitting on a new mount for me. This is a Skywatcher EQ6R. Those of you familiar will know that I've typically used an AVX, and while the EQ6R is definitely a massive step up in terms of performance, it's also a big step up in terms of the problems I'm having with it at the moment. And currently it's kind of disconnecting itself occasionally, which is a bit of a problem. Right, so that's the equipment. I'm using SharpCat Pro to do all the essentially real-time image processing. So images from that camera that is sitting on the back of the telescope are coming into this program called SharpCat Pro. It aligns the images. It does a process called stacking, which basically is a way of improving the signal to noise ratio, which basically means to say you get a better picture. I can then do some final processing, and you're going to be looking at the live image that I've got on my computer screen. So I don't do any visual observing at all. Dave is a big visual observer. He has a beautiful 16-inch Dob.
Yes, 16-inch Dob.
Yeah, he's got a really nice 16-inch Dob. I do everything electronically for reasons that hopefully you'll see shortly as we look at some of the deep sky objects in Orion. That's a list of all the software and hardware that's running this evening. I won't go through it, but it's there just for your information. And as I mentioned earlier, we're going to look at the deep sky objects in Orion from the perspective of Robert Burnham Jr. And particularly from what a book he wrote called Burnham's Celestial Handbook, An Observer's Guide to the Universe Beyond the Solar System. This is a quite an old book. In fact, it's been out of print now for many years. You can only buy it on the second-hand market. But Dave and I are huge fans of Robert Burnham, and I'm sure many others of you as well are probably big fans as well. And in my opinion, it's the best $40 you can spend in the telescope astronomy world. If you can get yourself a pristine copy, a second-hand copy of Burnham's Celestial Handbook, definitely worth spending the 20 to $40 that it's going to cost you. It's about 1,800 pages packed full of useful information, and we're going to be reading from some of his book this evening. And Robert Burnham was kind of an interesting character, kind of described in people that wrote about him, particularly Tony Ortega, as a bundle of contradictions. He was a recluse. He was socially awkward. He was brilliant and dedicated at what he did. He worked for the Lowell Observatory in Flagstaff, Arizona for 22 years, doing a survey work for them. And while he was doing this survey work, he did a lot of his own observing, and the notes from his own observing became the Celestial Handbook that he initially self-published because he couldn't get a publisher, and then it was picked up by Dover Publications, and now is kind of like, I guess, the Bible, if you like, for albeit it is a little bit old, but it is kind of like the Bible for observing. And we're going to be observing Orion primarily this evening, the constellation of Orion. It's rising at the moment. Orion is really signifies the onset of winter, and it is very much a constellation that many people look up into the night sky. It's one of the few constellations that most people recognize. You can usually see the belt of Orion. Orion was Orion the Hunter. You can see the belt, the shoulders, the feet, and the sword of Orion. And there are actually some fainter stars that make up the Orion constellation, which are actually his bow and also a raised arm. But typically, most people recognize Orion just by the shoulders, the belt, the feet, and the sword. And we are going to be looking around Orion and basically looking at it through the eyes of Robert Burnham this evening. And why Orion? Well, one, it signifies winter. It's very much a winter constellation. And secondly, and I didn't actually realize this, but it sits in the Orion Molecular Cloud Complex, which is a huge and vast area of nebulosities, star growth birth areas, and this graphic that we've got up on the screen kind of shows it. I picked it up off of one of the websites, and it shows you the many different areas of nebulosity that are in the constellation of Orion, and it's those that we're primarily going to be concentrating on this evening. So, Dave, do you want to add anything there to Orion? I may actually, while you're saying something, I may just open my book here, my copy of the Celestial Handbook, and see if I can pick a few choice phrases from Burnham and before we.
Uh, there's some interesting stuff in Burnham's notes regarding the constellation and many of the stars. Uh, for some reason, he went into great detail regarding the history of the name of Orion and the mythology surrounding Orion. Went back into many different cultures, different kinds of names, and shows the language history, the translation history, interpretations from a couple hundred years ago regarding some of these translations. It's very interesting. He describes, in general, he said, describes the Orion constellation as, we know it as the Hunter, but he refers to it as a giant or a warrior, and whose name was Orion. Um, and there's lots of different ways that different cultures have referred to this giant or the warrior or uh, I'm getting hand signals here. Okay. So anyway, this is there's a lot of stuff. If you have the handbook, there's probably 10 pages on description of the history of Orion and the star Betelgeuse. And we'll get into Betelgeuse a little bit later regarding that. There's a lot of interesting stuff there. But it is known as Orion the Hunter. He has the bow and arrow. The bow and arrow is allegedly aimed towards Taurus, the bull, who allegedly could be the target of the hunter, although most cultures that have the hunter concept would not be interested in slaying the bull because they actually worship the bull. So it's very confusing, and there's no real consensus of opinion about uh, where all these allegories and these mythological tales came from. But there's a great read in Burnham's books regarding the derivation of the name of the constellation and the stars. And it's, I mean, it would take me an hour to read this to you. So you need to read it for yourself. It's very enlightening.
So
So
I think,
Gary, go
yeah.
ahead.
So I think what you can say in general is that the constellation of Orion was extremely important to ancient cultures, whether that was Egyptian or Greek or Indian, et cetera, et cetera. And they saw it often as a god or um, um, a figure from, like, for instance, in the Egyptian, Orion was one of the most important sky figures to the ancient Egyptians and was regarded as the soul or incarnation of the great god of the afterworld, Osiris. On wall reliefs in Egyptian temples, he is often shown journeying through the heavens in his celestial boat, followed by Sirius, who is identified as the soul of Isis, and is shown as a kneeling cow with a star between her horns. So um, these constellations, because they were regular, because they also these ancient cultures, they associated with them with the religions that they followed. They became very important to them, and the rising of a constellation such as Orion was the signaling of moving from one part of the year into the next part of the year, etc., etc. And so yeah, and Burnham was really interested in what this meant to the Egyptians and to the Greeks and so forth and so on. And as Dave said, goes through it in quite some detail, and we'll skip over that for the time being. But it does make an interesting read if you've got any interest in ancient culture. Right, so this, I believe, is where we try and start the viewing part of the evening. And just to give Ryan a tiny bit more chance to make it over the rooftop of my neighbors, we're going to start by not looking at a target in Orion at all. I thought we'd look at a Messier object that is somewhat higher in the sky than Orion to start tonight's viewing, and that is the Messier object M77. And hopefully, by the time we've done that and picked up one more target on our way down to Orion, Orion will then be high enough that we can then concentrate for the rest of the evening on Orion and give you some of Burnham's thoughts on the constellation itself. So I am now going to transition over to my desktop, and you will see the sky map that I am currently using, which is Carte to Seal. And I am actually on the target M77, and it's possible that I may have actually been running some images on this. Oh, I'm actually just single snapshotting images here at the moment. So I am going to make a few technical adjustments here. I'm going to get my gain correct. I know my target's on track. As I said, tonight I'm actually going to be guiding, hopefully. Just to add to the complication of what we're doing. And I'm using a program called PhD2, which is kind of the de facto standard for guiding. For those of you familiar with PhD2, well, even if you're not familiar, essentially what we're going to do here is we are going to acquire a target star, which we have done here. And I am going to go into guide mode. And when I go into guide mode, this program is going to look at that target star. It is going to look at its relative motion, and it's going to correct for, and of course PhD2 is already giving me guiding errors here. Let's see. Okay, I think I might just close this down for 1 second. That was the one thing we didn't restart, Dave. So let me just close PhD2 down and restart it. oh, oh the joys of being an astronomer. That is the one problem sometimes. It does all get a little bit, sometimes there is just too much equipment going on. You've got to be a little careful that you don't overcomplicate things. So let's try again. So I've got my guide window here. This is what my guide camera can see. These are the stars that it can see. It can only see a couple of stars. I'm going to ask the program to auto select one. So it's done that. And this time I'm going to press guiding, and hopefully it's going to initiate guiding without giving me an error message. So let's see what happens. And we'll just give this a moment or two to, okay. So what you see here on this chart here is you see the guide error in terms of the RA and declination axis of the scope, and you see the correction pulses going from the guiding program into the scope to keep the thing on target. And we're actually guiding. So that allows me then to go back to my main program. It allows me to it allows me to increase my exposure time, and I'm just going to go up to about 30 odd seconds. And we are going to collect our first images this evening of the Messier object M77. And for that, I need to initiate the live stack. And so hopefully you are seeing on your screen now the first image is coming in. This green bar here indicates the exposure time. So we're doing about 30 seconds. And so we should see our first image come up in a few seconds now. And I'm hoping that we're going to see M77 right in the middle of the screen. Okay, that looks promising. So we are picking up M77. I'm now going to just do some quick adjustments here to start to hopefully bring this up and a little better. And I can immediately see that I have not applied my flats and darks. So Oh, that wasn't very. Okie dokie. Going to be one of those evenings, Dave. Let's go back to flats and darks.
Yeah.
So, you know, you could do this at home night after night and everything works perfectly, and then you try and do it in front of an audience, and there are times when it just goes completely wrong. So let me just sort one problem at a time. Flats and darks are just a way of correcting um, for variations in the sensor sensitivity and the optical chain and stuff like that. So that is why I'm doing that. And interestingly enough, let me start this looping again. Um, oh yeah, that's not good. Okay. What? Oh, okay. But there's the problem. Okay. Oh wow. Ah, okay. Well, that explains what happened. So for some reason, and this is, I guess, one of the problems I've still got to sort out with this new mount, Dave. It's telling me that I've hit a meridian limit, um,
Oh,
and I haven't. So clearly it's confused, but that's why it suddenly lost tracking. So let me okay, let me move my mount, and I'm actually just gonna park the mount and then restart it again. But it got confused there. It seems to have thinks it's hit one of its slew limits, which it obviously didn't do. So let me unpark that. Okay. So we'll try our next target. Let's try NGC 1683, which is just in the constellation of Orion. So this is going to be our first target. I am now slewing my telescope back towards the target, and hopefully I'm not gonna, and if you're seeing the screen here, you will see the big square moving across the screen towards the target NGC 1683. And there are a number of galaxies in the constellation of Orion. None of them are particularly big. Um, this happens to be a galaxy cluster, so I'm hoping when we look at it that we will be able to see, albeit that they're small, a number of galaxies. Right, so I'm on target. Now what I am going to have to do here is I'm going to need to plate solve to make sure that I'm actually pointing at the target. So let me go and do that first of all. And plate solving, for those that are not familiar, is basically the camera takes an image of the sky, compares it to a huge database of such images, and determines exactly where the mount is pointing. And if it's incorrect, it makes a correction for that. So it actually told me that I was on target. So I'm now going to go back through this process again. I am going to set my guider going. And I am going to just allow that to, yep, that looks like it's probably okay. I'm going to increase my exposure to about 30 seconds. And I am going to start my live stack. Okay, and I'm hoping that we are going to see our first targets in the constellation of Orion this evening, which is a group of, albeit small galaxies, which are on the towards the boundary of Orion. And what's the galaxy above Orion, Dave?
The galaxy above Orion?
Yes, I got it.
Oh,
I got it here. Hold on. Let me. Looks like we are. Okay, so we're capturing data, which is good. So I am going to quickly answer my question. So I'm going to transition. Okay, so we are. So here's Orion, and to give you an idea, the galaxies that we're looking at are just up here. Is this what's up in this area here, Dave? Okay, I can probably do it from cart to seal. Every time something bleeps at the moment, I'm like, oh dear, this is going wrong again. But okay, well, I'm not going to even try and answer that question now because I'm just going to go back to my image. I can see some galaxies forming here, thank God. And I am going to, we're going to take a quick look at these. So what we can actually see here is actually a number of different galaxies. We are centered on, I believe this is a small elliptical galaxy out here, and we have a cluster of galaxies that we have here, 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 and they're just a small grouping of galaxies that I thought I would um, bring up just to give me that little bit of extra time I needed for Ryan to rise sufficiently before I go into my next target. Okay. Dave, can you pull up the information on IC 421, which is going to be our next target?
sure.
And we are moving closer towards the lower end, the sort of area of the sword, or we will be in a couple of minutes once we've given these galaxies a okay, so let's have a look. Audio wise, we had a comment. Dave, audio cut out for a bit there. Just give me a quick 1, 2.
1, 2, 1, 2.
Yeah, you're fine. Okay, so the audio I think is working for everybody. We've been live for 32 minutes now. We have 18 online, so welcome. For any of you, I know where some of you are located, familiar with some of these names. Nice to see you again, Frank. For anybody else who's not gone in the chat window, if you've got the ability to go into the chat window, drop your name and your location. It's fantastic because it just gives me and Dave an idea of where you are. And we're actually it's a nice evening here. We were kind of a little bit worried about the potential for the weather this evening, but we've had cloud rolling through San Diego for about 10 days now, and we've been lucky. We've had 2 clear nights. And thank God we had a clear night last night because I literally had 2 or 3 hours of problems that needed resolving for this live stream this evening. We'd have never have made it on the air last night. So I'm kind of pleased at the moment that everything's still hanging together there, and we're managing to keep. Well, you can't see Dave at the moment, but I can see Dave's video feed as well. So as you can see, we've got somebody else local. Good evening, Tom, from San Diego and Rancho Penasquitos, just up the road from me in Scripps Ranch. So Tom will be able to see Orion rising in the southeast, pretty much with the same view that I am this evening. And you can see we've got quite a nice little galaxy cluster series of galaxies here. You can see them in a little bit more detail. I've actually pulled this into black and white just simply because it is much easier to see some of these galaxies in black and white. So I'm just kind of like taking a quick scroll through here. So you can see we've got a galaxy here. Looks like we've got a S-shaped galaxy in there. Probably is an elliptical galaxy right there. These are not actually covered in Burnham's notes for Orion. And like I said, I was really just playing for some time as Orion rises. So I'm going to move on to next um, the next part of our tour. We're going to go to IC421. So with guiding, you kind of have to do a little bit more work. So the first thing I'm going to do is switch the guider off, because obviously as soon as the telescope starts to slew, the guider will get a little upset. Well, it won't get upset, it'll just start bleeping at me. So now I'm going to slew my telescope. I'm moving on to IC 421. I am going to go into SharpCap. I'm going to turn my live stack off. And actually, before I get rid of that image, I'm going to save that just so that I've got a record of what we've seen this evening. I am going to type in my target name here, IC241. And I am going to do a plate solve just to make sure that we are in the right place. And kind of interestingly, with this telescope, once it's got itself sorted out, it seems to, and I probably need to actually adjust that a little bit. Hold on. So let me just cancel that 1 second. Let's bring that down to, say, and let's try that again. One of the things that this scope does seem to do, once it's worked out where its correction errors are, it seems to stay pretty much on track then, which is good. So here is the region of the sky that I'm currently looking at. You can see up here that we've grabbed a frame and we're now trying to plate solve it. And of course I said that too quickly, didn't I? Because it's now decided it doesn't want to plate solve, but okay, we'll give it a second.
So Gary, that's okay, because IC 421 is just below the tip of the sword. So you know, it's just right down there. Just kidding. So for those of you that are in the audience, IC 421 is a small, fairly dim galaxy, like a whole bunch of them in Orion. And it is below the tip of the sword. We know the sword area, that's where the Orion Nebula is. And there's not a lot of information. I haven't found anything in Burnham's books on this, but in Sky Safari there's a little bit of information. The visual magnitude says it's not known or not stated. So apparently no one has attempted to actually measure the visual magnitude of this galaxy. Many of them are like magnitude 15. So you cannot see these with the naked eye, or even with most telescopes. You really need to have some kind of a photographic process to see something that dim. So this one, estimates of its distance is 160 million light years away. That's a long ways, 160 million light years. If you think about the Andromeda galaxy, it's only about 2.5 million light years. So this galaxy is a long, long ways from here, and it's taken 160 million years for the photons, the light from that galaxy, to reach Gary's camera. So hopefully, if we can collect a few photons, it will be absolutely amazing. But we will see how that goes.
Okay, well, I've got my first image come in, which is great. So while it's just collecting a few more, and it said I was on target, which is good, apart from the fact that I don't see a galaxy in the center of this image at the moment. But we'll figure that one out at the moment. So I'm just going to go to the chat. Morning, Ross. So Ross is the president of the Bolton Astronomy Association in the UK, a good friend of mine, and often joins for a live stream. So fantastic! It's pretty early in the UK, so great to have you on board. You joined after, well, you joined in.
Maybe,
Let's just check my audio there. You joined in time to catch us actually getting onto Orion. We've had numerous technical problems so far this evening, most of which actually we did manage to solve before we got on air. But at any point here, this entire thing could collapse. So we're just keeping our fingers crossed. And also, yes, Dave was saying that IC 421 is a 14.2 magnitude galaxy. So I'm hoping I'm going to be able to.
So, Gary, in checking the star chart, you're dead on the location.
Okay.
It should be pretty much centered, and that is according to the Sky Safari star chart.
Okay. All right. I don't. What's going on here? Just something is not 100% working. Hold on. Let's just wait for this frame to come in. Okay, so it's not stacking. Okay, so I don't know. Okay, we're going to need to. Okay, what is going on here? So for those of you who are, I'm collecting frames. I'm not dropping anything, but nothing is stacking. Something is awry here at the moment. It's because I'm also not, I don't have control of my image, which is here at the moment either. So I am going to quickly restart SharkCap here because I do not understand.
Would this be a good time for me to make some comments about Betelgeuse?
Sure. Why don't you make a few comments about Betelgeuse while I go and put my head in a bucket and cry?
No, don't do that. This is so much fun, Gary.
Do you want your slide deck up? Do you want the?
Any time. Yeah, that's not a big hurry. I actually also have Betelgeuse on in my scope, but I don't know if it's. I mean, it's just a big orange star, so
Yes.
not much to see.
And I don't think trying to get your screen up on my OBS feed is going to be the right thing to do, judging by the problem. So what you've got up on the screen at the moment, Dave, is I've actually brought up the raw spectrum of Betelgeuse. So why don't you talk about that?
Good.
And I will restart SharkCap here.
So Betelgeuse, very interesting. Burnham has a lot of history about the name, just like he did regarding the Orion. Basically, Robert Burnham describes Betelgeuse's name as meaning armpit of the giant. Others have softened that a bit and said the shoulder of the giant, or the shoulder of the hunter. But I thought that was very interesting that in Burnham's handbook, he said the best description and translation of the words is armpit of the giant. So if you think about it, thinking about the Orion constellation, Betelgeuse is on the upper left corner, very obvious orange star, and that is exactly where the hunter's right shoulder is. So he's holding a bow and pulling the arrow back with his right arm, so his elbow is up sort of in the air, and lo and behold, the location uh, of Betelgeuse is actually the right armpit of the giant. So I think that's a pretty good description. Very, very interesting. So a couple of things. There are two main scientific processes that we use for studying stars. And these processes have been developed since about the early 19th century, early 1800s. And these two processes tell us about stars more than anything else. The first process that we might talk about is how bright a star is. Now, we've talked about how bright a star is tonight. We've used the term magnitude, which is a way of talking about the brightness of an object. And it's very interesting. The magnitude concept is very, very old. It predates any photographic capturing of stars or images. So basically it refers to how bright something looks to you in the sky. So it's basically a human eye vision tool to communicate how bright something is. At the time it was initially created, the magnitude scale had 6 steps, magnitude 1 through magnitude 6. Magnitude 1 was the brightest object that you could see, the brightest normal star, and magnitude 6 was the dimmest star that they were able to see with the naked eye. And all the stars between magnitude 1 and 6 were given numbers. So this system has been developed in more detail over the decades, and it now refers to a logarithmic scale. So it's not a linear scale, 1 to 6, it's logarithmic. And basically, the brightness from magnitude 1 to magnitude 2 is a factor of 100. So if you think about that, magnitude 6 drops by a whole lot from magnitude 1. So that's just a little bit about brightness. Well, the science that we use to describe how bright something is in the sky is photometry. So we take photometric measurements of things in the sky, and we measure how bright they are, and we measure how their brightness changes over a period of time. So the fluctuations in brightness makes a graph, and the graph goes up and down depending on how bright something is. I mention this because Betelgeuse is a variable star. Betelgeuse changes brightness, and it's been known since, I think it was actually John Herschel, I believe, is credited with the first one to actually document the change in brightness of Betelgeuse over time. And now we know that there's a couple of brightness changes for Betelgeuse. One is over a period of 5.9 years. So in a period of 5.9 years, Betelgeuse gets bright, and then gets dim, and gets bright again through a cycle. So that's the long period. The short period of changes is on the order of about 425 days. So it also has a brightness change that changes through that cycle, and the two cycles are on top of each other. So occasionally they add together and make something very bright, and occasionally they are both in their dim mode, so the star looks quite a bit less bright. Now, if you are an astronomer and if you've been watching the Orion constellation over the years, you realize that in general, Betelgeuse, the orange star on the left, is about the same brightness as Rigel, which is the bright blue-white star on the right. And those two stars, Betelgeuse and Rigel, are iconic when it comes to the description and the location of the Orion Nebula. But about a year ago, maybe a little more than a year ago, for some reason, Betelgeuse began to get very dim. And it was actually quite noticeable if you're watching the sky with the naked eye. You look at Betelgeuse and Rigel, and we realize that Betelgeuse isn't near as bright as Rigel. It's gotten very dim. So that's a very interesting thing that we have not yet fully worked out. There was a lot of hype in the media about the possibility of Betelgeuse becoming a supernova very quickly, and everybody was teasing about, hey, we better check Betelgeuse tonight because it might be a supernova. Well, it's eventually will go supernova. That's the prediction for this star, but probably not anytime soon. So that brightness change is very interesting, and we measure brightness by using a process called photometry.
Hey,
The
Dave.
other scientific process that we often use is a process called spectroscopy. So where photometry measures how bright something is, spectroscopy measures what color something is and the combination of colors in the light. So we take the light from the object, the star, like Betelgeuse, and we run it through a spectrograph, which is a combination of a prism and gratings and some lenses, and it breaks it out into colors. Now, you've all seen this where sunlight passes through some transparent object and creates sort of a rainbow effect from the light. Well, that is a very basic type of spectrometer. Light comes in different colors. It's all joined together when we see it with our eye. What we see is the combination of all the light. But a spectroscope will break that out into its various wavelengths. And what we can do with that is scientifically break it out into its wavelengths, measure the wavelengths and the intensities of light at that wavelength, and determine a whole lot of things about a star.
Hey, Dave.
So,
Just gonna interrupt you for a minute there. Two things. One, I do have images back up on my desktop again, and
Good.
secondly, I've moved you to your second screen there, which is the spectral analysis of Betelgeuse.
Okay. Great. So on the screen that was just up, that was a raw spectrum that I photographed of Betelgeuse about 2 months ago. And basically what I do is I have fashioned a small spectroscope, point the telescope at Betelgeuse, and I take a series of images through the spectroscope, which breaks out the light into a broad spectrum. And in that image that was up a little while ago, there was a bright star on the left, that was Betelgeuse, and then it was sort of a line with a bunch of variations in it on the right. So the line on the right was the actual raw spectrum that came from Betelgeuse. Now, what we do is we take that image of the spectrum and we use some software. I'm using a software called RSpec, and we analyze the image of the spectrum. We find out what frequencies are represented and how much flux or how much intensity we see at each frequency. So on the screen right now is a graph, and along the graph at the bottom is a bunch of numbers that represent the wavelength of light. So very short wavelengths of light are on the left-hand side, very long wavelengths are on the right, and the height of the graph on the scale on the left has to do with the amount of flux or the amount of light at that particular wavelength. So as you can see, there are peaks and valleys in this graph that represent the chemical composition and many of the parameters concerning Betelgeuse. And I'll make a few comments about this. in this kind of a star, the most visible thing for us are the valleys or the depressions, and those valleys we call absorption lines, where light is absorbed and reduced in intensity for that particular frequency. So the absorption comes from the outer layers of the star, from the corona, the photosphere, and the chromosphere. They absorb light coming from the core of the star. And as those outer layers absorb the light, it creates these dips in the spectrum. Now, we can tell a lot of things about that star because each of those wavelengths represents certain kinds of chemicals or certain kinds of states of energy or matter. And we can correlate that to various known elements and their electronic states or their energy states. The other thing we can tell about a spectrum like this is if you were to take and draw a line across the tops of all those curves and make a nice smooth curve, you would see that it's a little bit slow slope or a very gentle slope on the left-hand side, and it comes to a very high peak and then drops off fairly quickly. But if you drew that line, the highest point on that line would be somewhere, and I can't see the numbers, but it's probably somewhere on the order of about 7,000 angstroms. So that's a pretty red or pretty long wavelength. 7,000 angstroms and above is pushing in almost into the infrared. At least it's in the red end of the visible spectrum. So basically, that represents the general color of the star. It also represents the general temperature of the star. So from that curve, that wherever that curve peaks, it helps us to understand what the approximate temperature is of the photosphere of the star. So this is my spectrum from 2 months ago of Betelgeuse. And by the way, Betelgeuse is a type M star. So if you don't know about star types, there's a classification system. Oh, be a fine girl, kiss me. It's a very interesting classification system, and but it works very well to help us remember, what we're doing. Well, M is at the sort of the coolest star in that list. O is the hottest star. So Betelgeuse is an M star. It's very cool in temperature compared to the other stars we've attempted to classify. So we can tell that by this spectrum is a good example of what an M-type star looks like. So Gary, do you have that next slide?
Yeah, I do. And I'm about 9 minutes now into imaging the open cluster above the Sword of Orion. So when you're finished, I can bring that up.
Okay. The next slide, I'll see it here in a minute, is a spectrum that I took of the star Vega. And Vega is a type A star, which is a fairly standard, bright, white-looking star. And we use Vega because it has a very clean, nice spectrum. It's a classic type A star. It's much hotter than Betelgeuse. And if you see this spectrum here, if you were to draw a line across the top of that spectrum, it has a very steep slope on the left, and it has a peak, and then a slow slope going to the right. Well, the peak of that line would be at a much shorter wavelength. And again, I don't have the actual numbers, but it's probably on the order of maybe 4,500 angstroms, which is a much shorter wavelength than the 7,000 angstroms we see with Betelgeuse. So Vega is a much hotter star, and we can tell that by the overall curve. We also see in Vega, there's a couple of very nice dips, 1, 2, 3, at least 4 dips there. And there are blue lines associated with those dips. The blue lines are what we call the hydrogen Balmer series of absorption lines. So H alpha, H beta, H gamma are the names of these lines, and they're very, very common in standard main sequence stars. So when we look at this image of the spectrum of Vega, we find these dips, and the blue lines correlate very nicely with these dips. So we use the star Vega to calibrate my spectrometer. So I would take the image, I would recognize those dips, and I calibrate the scales along the bottom so that they coincide with the hydrogen Balmer series, and then I use that calibration. In fact, I did use that calibration when I took the image of Betelgeuse. But here's a great example where a type A star like Vega has a completely different spectrum than the type M star Betelgeuse, and comparing these two spectrums, tells us a whole lot about stars. Now, my spectrometer is working in the range of visual light only, and it's a very low resolution spectrometer, whereas the professional spectrometers work in very narrow bands of light, possibly only 1,000 or 500 angstroms in width, and they break it out very, very precisely, and they can tell an awful lot of things about stars by looking at the absorption lines or the emission lines in that spectrum. Anyway, this is just a good example, and it shows us how interesting Betelgeuse is, especially in the last year with us seeing it diminish in light. Everyone has been interested in what's happening with Betelgeuse. So at this point, we don't think that it means there's anything going to blow up. It's not going to do a supernova immediately, but between the photometric and the spectroscopic analysis, the current thinking is that the star had essentially a whole bunch of large sunspots that blocked the light. And because the temperature of the star did not change over the time period, and the basic changes that we did see were in the ultraviolet end of the spectrum, we don't think that the star has changed that much. We think that it was just the light was blocked by something like possibly a large sunspot. So anyway, that's the latest update on Betelgeuse. I don't think we can do too much about that. You're probably bored to death already about this little bit of science. But anyway, Gary, what do we have to take a look at here?
Yeah, so since Dave dug me out of a hole there as my Sharp Cap tool crashed, I was able to restart that. And what you are now seeing on the screen is a image that I've been taking 40-second exposures with. I've now stacked 21 frames, so about 15 minutes of image, and we are looking at the open cluster, which is just north of the three stars that form the Sword of Orion. And this is the open cluster NGC 1981, which was discovered by John Herschel in 1827. It's about 28 arc minutes across, which, as you can see, kind of nicely fills the field of view of my telescope, which is pretty much 30 arc minutes. It's 0.5 degrees. And interestingly enough, not only can we see the open cluster, but we can also start to see some of the nebulosity now that the Orion constellation is famous for. And you can see you can see large areas of nebulosity here to the left-hand side, and you can actually see a really interesting structure right on the corner of the image here, which is three bright stars that also appear to be formed a reflection nebula as well. So this image now has been formed for quite some period of time. Of course, I managed to forget to change my target name, so when I save it, I'm going to get the wrong name, but I am going to save it, and we are then going to move on to probably the most famous nebula in the Orion constellation, and that is the Orion Nebula itself. So, Dave, before I move on, is there anything that you'd like to add with respect to NGC 1981?
Um, no, not really. I'm using Sky Safari at this point. Not a lot of information. We believe that this cluster is about 1,200 light years away. We believe its visual magnitude is 4.19. Now remember, we talked about visual magnitude. The higher the number, the dimmer it is. But 4.19 is usually bright enough to see visually under a good clear sky. So I don't have much history on this.
Okay, no problem.
Yeah.
I've slewed the telescope onto M42. I have initiated the guiding once again. So I am going to now clear my stack here. And we are going to collect our first images of M42. And because this is just such a bright nebula, I'm actually going to clear that stack again. There we go. I'm actually going to bring my sub time down to about 15 seconds because I can collect a lot of data and we can see our first image pretty quickly. And we've been kind of struggling to see images this evening. So let's get something up on the screen. So this is the Orion Nebula. And I am just beginning to get that coming up on the screen now. Okay, and right, here we go. So, I will adjust this in a few moments to make this a little cleaner. But before I do that, in fact, let me do that quick adjustment here as we allow a few images to come in. So the Orion Nebula M42, and I'm going to be reading directly from Burnham here. And let me just check that my audio, yeah, my audio is still running here. This is the great nebula in Orion, considered the finest example of a diffuse nebula in the sky and one of the most wonderfully beautiful objects of the heavens. And in fact, I think you can see this is a pretty incredible image that we have formed here, probably with only we 60 seconds of imaging, and you can already see the core area showing bright white, and the expanding Orion Nebula. Now, the Orion Nebula is considerably bigger than the field of view of my telescope, so we're actually really only seeing the first part of it. If I actually wanted to show this image in its entirety, I would probably have to put a mosaic together. But obviously, we're not going to do that this evening. So again, to quote Burnham, it may be seen in a pair of field glasses as a faint haze spreading out from the famous quadruple star Theta in the middle of the Sword of Orion. So when you look at the Sword of Orion in the sky, you will see three stars in a line. Well, the middle of those three stars, Theta, is actually a collection, a quadruple star, and in fact, it's even five or six stars, but it's generally known by the four brightest stars for the called the trapezium. Um, so this is effectively the middle star in the Sword of Orion. Um, in a small telescope, it appears as a bright green mist enveloping the star. Now, what you often find is that when you're doing visual observing, because of the way that your eye receives light, you tend to see things pretty much in black and white, or with a slight greenish tint. So you tend to miss the colors that we're seeing on this, the screen this evening, because actually the Orion Nebula is a vast collection of reds and purples and whites, as you see these filaments coming out from this central area. So,
Gary,
yeah,
I might mention here from Burnham's book, he makes a note here that M42 was the first nebula to be successfully photographed by Henry Draper in 1880 using an 11-inch refractor, and his exposure time was 51 minutes. So at this point, they did not know what nebulas were. And but this one was the first one actually successfully photographed.
yes, and it is not surprising since it is one of the probably, I wouldn't say easiest objects to photograph in the sky because it has an extremely high dynamic range. And in fact, we're going to do some more imaging in a couple of minutes that will actually show the core. And typically, when you see a picture of M42 as we're seeing at the moment, it's pretty much in this format. Where the core is completely blown out because the dynamic range of the target that we're looking at is so high. So this area here, we cannot see the four stars that provide the light that basically light up this reflection nebula. And uh, this area here is known as M42. This area here, which is slightly separated, is known as M43. So we're actually seeing two Messier objects here as classified by Charles Messier, M42 and M43. And M43 is actually lit up by the central star. You'll also see some very dark areas here. And what you will see throughout the Orion Nebula or throughout the entire Orion region is that you will see a lot of dark nebula, and these are very thick dust clouds that are in fact in front of the nebula that we see behind, and they actually block the light and from the nebula and from stars from coming through it. And so you see these channels that almost appear to be cut into the nebula itself, but in fact it's actually an object in the foreground that's stopping light coming through. Um, so Burnham went on to say, in a moderately large telescope, its appearance is impressive beyond words and draws exclamations of delight and astonishment from all that view it. The great glowing irregular cloud, shining by the gleaming light of the diamond-like stars entangled in it, makes a marvelous spectacle which is unequaled anywhere else in the sky. And I think that's absolutely true. Certainly viewing from the northern hemisphere, the Orion Nebula is without doubt probably the most impressive nebula that we have available to us. Okay, so we've seen now, and we're doing this in relatively short imaging here. We've got 6 minutes of imaging. Here is my histogram that I'm just going to look at. I'm pretty much color balanced. And I'm pretty happy with this image at the moment. We can see really a lot of detail in the nebula itself. We can see a lot of stars that are either within the cloud or sitting behind the nebulosity. So now what I'm going to do is I'm going to change the parameters of my capture. So the first thing I'm going to do is save that image. And I'm now going to look at the trapezium, which is the 4 stars in the bright area here. And in order to do that, I'm basically going to drop my exposure time down to about a second. And I'm going to restart my stack. And I'm going to let this capture some fast images. What happened? Okay, cool. So I'm now actually collecting images. So now I've basically come down from about 15 seconds to about 1 second. So we've come down, what's that, about 5 f-stops, if you were thinking about this from a photographic perspective. And that allows me to obviously look in detail now at the central part, which was blown out in our previous image, and of course we've lost now the detail surrounding it. So we're going to zoom in into this area so we can take a closer look. And I am going to, yeah, okay. We can quite clearly see now the 4 stars that make up what's called the trapezium. And again, to quote Burnham, I am going to, here we go. So Burnham says this is probably the best known multiple star in the sky and one of the most interesting for the small telescope. The 4 bright components form a little quadrangle called the trapezium, and the object is favorite amongst all observers. He goes on to say, the trapezium is the bright core of a compact cluster of faint stars which may form an expanding association. Within 5 degrees of the trapezium, there are more than 300 stars brighter than magnitude 17. A study of this group has been made by K.A. Strand. He finds some evidence for the expansion rate, which would indicate an age of no more than 300,000 years, and this makes it one of the very youngest star clusters known. The conclusion also appears to be verified by the color magnitude diagram of the group, which is very similar to the diagrams of other young star clusters such as NGC 2264. These star groups, the fainter members, have not reached the main sequence state and may still be contracting gravitationally. So what we're actually seeing here is we're really looking at a area where stars are forming. And the whole Orion Nebula is an area where the gas and the dust that we're seeing is actually giving birth to new stars on an ongoing basis. Dave, do you want to add anything to the trapezium?
Uh, for visual observers with a large scope and a good sky, the trapezium not only has those 4 stars, but it has at least 2, there's actually 3, that can be seen by large scopes. In my 16-inch Dob, I have seen the E and the F stars for a total of 6 stars in the trapezium. I'm sure it's possible to photograph it, but you would have to reconfigure your system to be specific for that, for that object. But there are many stars there, and like you said, I think I think Burnham said 300 stars brighter than magnitude 17. I think is what he said in that general area. So yes, it's a very active star-forming region, and it is a wonderful object to examine.
Yes, and this image that we're now seeing on the screen is certainly not one that you see many times, either from the astrophotographer. Well, you perhaps from the astro guys who can do a lot of image manipulation. You might see the 4 stars or the multiple stars that form the trapezium, but certainly for when you're looking at EAA, typically the first image is very common where you see the blown out core. But simply by dropping the exposure, we can now get to see those 4 stars, which are in themselves actually extremely well known. Okay, so we've done a couple of nice images now of the of M42. I am going to save that because I don't think I've actually got that image so far. And I am now going to move on to NGC 1977. Right, so let me just try and get my head in order here. Let me stop my guiding. Let me slew my scope. And what's kind of nice about what we're doing this evening is that the distances that we're actually traveling are extremely small in terms of angular movement of the scope. So the scope literally is just moving fractions and then stopping. So we're not bouncing around the sky as you often might do on a typical observing evening. We're staying very concentrated. So now I'm actually going to pick my guide star for this latest acquisition, and I'm going to start my guiding off again. And as you can see, the previous guiding there was actually going extremely well. It's kind of interesting. This scope appears to go through periods where the guiding gets extremely good, and then there are periods when the guiding seems to go all over the place. So I think this is still very much a learning process, and I've got to figure out um, perhaps some more optimal parameters because literally I switched PhD on, ran the calibration once, and kind of expected it to run, which it is doing, but probably not as well as I would like it to. So I'm just going to let this settle down a second here because as you can see, my scope is bouncing around a little bit. You can see now the calibration, the correction pulses coming in from PhD, the vertical blue and red lines. We're just letting this settle down. That's probably beginning to settle, hopefully. And we're going to move on to our next target, which is NGC. Well, we're already there, 1977. I am going to increase my exposure time, and I think this time I'm going to run at a full 60 seconds of exposure. This you would not be able to do if you were not guiding. It would just be asking the tracking on the scope to be doing too much, and you would start to see elongated stars. But by guiding, it keeps the stars nice and circular. So let me reset my stack. And we are collecting our first image of NGC 1977, which is the nebula that sits again just north of M42 and M43, and this is known as Shapeless 279. It's a hydrogen alpha region, and I can see that our target has come straight up in the screen here with our first 60-second capture. So we're going to let a couple of these capture, and then I'm going to adjust it. And it's got a very famous name that hopefully you will be able to see in a few moments. And I'm just going to hopefully find my way into the right place in Burnham while we're doing this. Right. And that image is beginning to form. Now there is kind of a bit of a debate whether you should use a long or short of exposures in the EAA community. Typically it's normal to use much shorter exposures than this. But the advantage of using these longer exposures is it does pull out a little bit more of the finer detail, and that's what I'm hoping to do in some of these images for you this evening. And so I am going to bring my histograms in. Here we go. We're beginning to form we'll let that image form a little bit more here. And this is nebulosity that surrounds the star 42 Orionis, and is about half a degree north of the main mass of the Orion Nebula. And in Burnham's Celestial Guide, there is on page 1336 a picture from the 42-inch reflector scope at Lowell of this nebula, and we're seeing pretty much this picture. In fact, I would say the quality of the picture that you're actually seeing on the broadcast is significantly better than the one in the book. That is actually showing some elongation of stars, so clearly there were some tracking issues going on. But hopefully now you will perhaps be able to guess, if you don't already know, what the name of this particular nebula is more colloquially known as. It's called the Running Man Nebula. And we have our man here. The bottom is actually down here, so his head is here, his arms are here, and his legs are here. And you can see this nebula kind of makes this rather nice picture of this man running, which is where it's picked up his name. And you'll find that the name of many of the nebulas, the sort of colloquial name, is very much determined by the shape, what people see in it. In fact, on the and I was hoping to image it, but it really, with my telescope with only a half degree field of view, it doesn't really work. But there is the Witch's Head Nebula, which is also part of the Orion Nebula. Not the Orion constellation, but that's 3 degrees across by a degree wide. So obviously, when I've got such a small field of view, it's somewhat difficult for such large targets. But this one fits the field of view really nicely, and we're beginning to see a quite nice picture here forming of the Running Man Nebula.
Gary, I think many of the people in our audience might not understand the term nebula and how we're using it.
Sure.
Basically, a nebula is just a cloud of gas in the sky, and but there are three basic types of nebulas, and these pictures here, the Running Man and M42, demonstrate those kinds very well. So one type of nebula is what we call a reflection nebula, where it's basically a cloud of gas which is bombarded by ionized particles and light from a bright young star. So the bright star energizes this gas, and what it does is it reflects the light, just like smoke in a room when you turn on a light bulb. And so that's a reflection nebula, which is just basically reflecting the light from the star. Then you have emission nebulas, which that ionized flow from the star actually causes chemical and electrical reactions within the star and makes it fluoresce, or it's more like a fluorescent tube or a neon type sign, where an electric charge causes the gas to actually glow. And so that is what we call an emission nebula, because it's actually creating the light because of the energy being bombarded from the star. The third type of common nebula is a dark nebula, which basically, and Gary mentioned it in a discussion of M42, it is a cloud of gas that is between something bright and where we are. So that cloud of gas blocks the light from whatever is behind it, and it looks like a dark shadow. So basically, that is not reflecting or fluorescing any light. It's just blocking the light from behind it. So the three basic kinds of nebulas we see when we talk about nebulosity in the sky are nebulas that reflect light from a nearby star, nebulas that are bombarded by high energy and they create their own light and they're emitting light, emission nebula, and then the dark nebula, which blocks the light from whatever is behind it.
And what's kind of cool, Dave, is that wherever you look in the constellation of Orion is, you're kind of almost, in fact, seeing uh, often in your view the three types of nebula that you've just mentioned, right? We have dark nebula here, quite clearly showing up below the Running Man. We have emission nebula, and we also have, you can see the reflection nebula here. So I think often you are seeing in these images either two or three types of nebula in sort of one go. You get a big bang for the buck in the Orion Nebula, or the Orion constellation, I should say.
Yes, you
Yes, you
Okay.
do.
do.
Thank you for the comment there, Dave. Yeah, this is a pretty cool image. We are seeing some nice images this evening, and that I'm pretty pleased with that picture of the Running Man. So I'm going to save that now. We're now going to move on to our next target, which is called B33, albeit that once again this has a colloquial name, which is far more descriptive of the actual target. So, and I'm going to do the same thing. I'm going to stick with 60-second imaging. I am going to switch my guiding off for a second so that I can move my scope. Okay, so I've just moved my scope, and where we're actually going now. So now we've moved from the sword, and we're now going to the belt. And if you were looking at the Orion constellation, this is close to the lower of the three stars in the belt of the constellation of Orion. That's the kind of area that we've moved into. And we're going to take a couple of images in this particular area. Right, so I'm going to start my looping again on my guide scope. I am going to select a guide star. So my scope is hopefully gonna start guiding here shortly. Looks like we're away. I am now going to go and change my name here to B33. I'm going to clear my stack, and we're going to grab our first 60-second image of this nebula, and then I will go through some of Burnham's notes on this particular nebula, which is actually extremely famous and well photographed. It's a very popular target for astrophotographers in particular. So this first image will be coming up shortly. Interestingly enough, Dave, I when you were talking there back about Betelgeuse and the spectrum analysis and stuff like that, I was trying to switch from the slides to the sort of interview screen, and we've got a weird audio thing going on now in OBS that I don't quite understand. So at the moment I can't put the interview type format up because I seem to be getting your audio twice, which is making your audio levels jump a bit. So we might play around with that in a few moments. And here we are straight away. And our first image here is actually pretty good. And perhaps, well, I know many of you who are actually on the stream already know this, but this is is colloquially known as the Horsehead Nebula. Um, this being a dark nebula in the shape of a horse's head. And so Burnham said, this is the famed dark Horsehead Nebula, undoubtedly the best known example of a dark nebula in the entire heavens. It is almost completely invisible to the eye at the telescope and requires long exposure photographs to reveal its strange and spectacular details. Now, interestingly enough, when Burnham wrote this book, which was back in the late 60s, that may well have been the truth. But as you can see here, with a fairly modest telescope, within a 60-second exposure, we've actually managed to create, a pretty reasonable image. And now as we grab a few more frames here, hopefully we will be able to improve that. This is located about half a degree south of the bright star Zeta Orionis in a long stretch of nebulosity IC 434, which extends for about a degree south of the star. This nebulosity was probably first detected by Pickering on photographs made in 1889. And the dark Horsehead itself shows clearly on a plate made in 1900 and published in the Astrophysical Journal in 1903. The significance of the object was not immediately recognized, and the early descriptions refer to it as a bay or gap in the nebulosity. Bernard seems to have been the first to recognize it as a great obscuring mass of some sort seen against the bright region of nebulosity behind it. And we have hopefully our second. Yeah, we've now got 3 images in for about 180. Actually, yeah, 3 minutes of imaging.
Gary, I was going to say, Burnham also claims that the visual observer, not using a camera, it might be possible to get a hint of this outline of the nebula with a fairly large scope under a very pristine sky, and if you have a good trained eye. According to Burnham, he says that a good 8-inch or 10-inch telescope with a wide field eyepiece might actually display the outline of this shadow. Although I've attempted to view the Horsehead with my 16-inch Dob and have not yet been successful, maybe because I'm not in good pristine skies. But it is interesting that he's claimed that it can be done.
Yes, and it is interesting. I mean, one of the things that Dave and I often do when we're, or we were doing last year, I would say, certainly not in 2020 with the pandemic, is we will often run the 16-inch Dob next to my EAA setup. And I remember when I first started, we started doing comparisons of the images that we could see both visually and with EAA. And it is interesting to be able to do that and see some of the things that show really well visually. I mean, globular star clusters, for instance, are some of the things that show extremely well visually. They show well in EAA as well, but because of star bloat and stuff like that, you don't get the impression of it there being so many stars. You can see hundreds of stars for sure, but you can't see the thousands that you can see if you're doing it visually. Whereas something like the Horsehead, for instance, I mean, this is a classic example of something that shows extremely well with an EAA setup, but is perhaps somewhat more difficult to view visually. And again, this is kind of a nice image. We can now see the Horsehead. And if you allow this to develop with more time, you will actually start to see some filaments in the actual Horsehead itself. It's not a solid mass. There are some filaments that begin to form. And again, we've also got a nice example here of another type of nebula showing up. We've got our dark nebula, we've got a reflection nebula, and this must be an emission nebula, right, Dave? The red area here. So we're basically seeing all 3 types.
I would think so. Generally, the emission nebulas have a lot of the hydrogen alpha frequency at 626.28 nanometers, and that's that red color. So, yeah, it's more than likely, an emission nebula.
Yeah, so we're really seeing all 3 types of nebula in a single shot here. And for those of you who've got really good eyes, and I'm not sure if it's actually showing up on the YouTube stream, but we've also got a little bit of a dust bunny showing up right here as well that my flat obviously hasn't taken completely out, because I can just see a circular dust bunny there. But I'm not sure if that shows on the YouTube stream or not. Right.
Going back, Gary, a comment you're saying working side by side, visual techniques and photographic techniques. I can only hope that sometime not too far down the road, you and I can do that again and invite people to come out to the park and actually make that comparison. So I'm
Yes.
still looking forward to doing that.
Yes, and I think, to be fair, we've made some huge. Oh, the dust bunny is visible. Thank you, DJ. I'm glad you spotted that because I certainly did. I pushed the processing a little bit there. So let me just perhaps reduce. I think I can probably get rid of the effect, most of the effect of the dust bunny. There you go. There. So yes, so I'm going to save that image. I think we probably, and that's only 8 minutes of imaging here. The guys who are doing the astrophotography, if you look at images of the Horsehead Nebula, some of them will have been collecting 3, 4, 5, 6 hours of data to put their images together. So you can imagine the level of detail that those guys are able to achieve. But I think for 6 minutes, which is practically real time, we've done a really good job of seeing what is actually a relatively difficult target. And we're now literally going to push the scope just a few arc seconds away from the Horsehead. We're going to move up the nebula. We're going to basically move in this direction. We're going to go up the lane of this nebulosity, and we're going to go along, if you could imagine the nebula spreading out here. It then turns and goes up in this direction, and we're gonna go up here, and we're gonna image this area over here. So that's going to be our next target. So I'm going to go into PhD. I'm going to switch my guiding off again. I'm going to initiate my slew, which literally is already done. I'm going to pick up my another guide star. Yes, that's actually, I think we've moved so little that you can actually, and we may have to move again, actually, I'm not too sure. We've moved so little that I believe that was the area of reflection nebula that we could see a moment ago. Okay, let me grab a guide star here and stop talking. Okay, let's start the guiding. So we're basically locking the telescope into that star so that I keep nice round stars when I'm doing these long 60-second exposures. I'm going to put my name in here, NGC. What was that? 2023. And I'm going to reinitiate my stack. And one of the things that those of you who are familiar with my AVX, when I've been doing live streaming with my AVX mount, um, because the mount, I mean, it's a decent enough mount and it's great for EAA. It's nice and lightweight. But you will have noticed that I would plate solve every time I went onto a new target. Now, admittedly, we're not moving very far here, and that may be part of it. But I do find this mount, once you've done your initial plate solving and it's kind of worked out what the error is, it seems to do a pretty good job then of oh, actually, I am. I had a feeling that yes. So when I set up my observing list, yes. So I set my observing list up to actually show this reflection nebula, but we'd actually caught it in the previous image anyway. So I'm actually just going to move on from this target and go to my next target. I had a feeling we hadn't moved quite far enough, but okay. So let me just go on to the next target, which okay, which is NGC 2024. So
Yes.
I'm going to move once again. I'm going to reinitiate my guide camera. Going to grab a guide star. Going to start guiding on that star. So I need to change that to 2024. Oh yeah, there we go. And yeah, okay. And I'm going to clear that stack. Right. We are now moving on to, like I said, we've just kind of moved along the nebula. We've turned the corner, and we are now looking at another pretty spectacular, or we will be in a couple of minutes, looking at another area, a pretty spectacular nebulosity, which again, it tends to get photographed on a fairly wide scale basis. So we'll wait for that first image to come in. I'm kind of interested if anybody's got any comments in the audience here. Normally if you're watching a live stream, you're used to sort of 5 to 15 second um, stacks. Here we're doing 60-second stacks. Does anybody find this too slow? Um, would they prefer perhaps a little less detail but a quicker image, or anybody got any thoughts about that? But here we go, our first 60-second image, and we have a pretty good first rendition of what's known as the Flame Nebula. And we also have the lower star in this field of view of the belt of Orion, and that would be which star, Dave? Just remind me.
Alnitak.
Ornithak, thank you. And so you can see the lower of the three stars in the belt of Orion, and next to that you can see the Flame Nebula, and that's already beginning to form. Just off that first image was a pretty nice image. So we're going to collect a few images here and just adjust this a little bit so that we can get the best image we can. Okay, so DJ said exposure time is fine. Air, love the detail. Okay, anybody else got any thoughts or comments on the longer exposure times and just having to sort of wait that little bit longer to see that first image? It does feel, I must admit here, like an eternity as that first image comes up. But it's probably because I'm not really that used to this sort of longer exposure time at the moment. But I certainly do like some of the detail that we're getting on some of these images. And for anybody that's watching who is planning to do the observing challenge on cloudy nights for January, you will have somewhat of an advantage going into that, because I'm actually the one setting the list of targets for that January. I think I'm also doing February as well, but I'm certainly doing January. And I am going to be doing it based on the Orion Nebula. We are going to be using some of the easy targets we've shot tonight, and we're going to be looking. I'm also going to be some of the more difficult targets that we have looked at this evening. So this image is beginning to form. About 3 minutes of imaging.
Gary, I'd like to make a shout out here to
Sure.
A fellow SDAA member and good friend of mine, Carl Weber. I happen to have an image that Carl made of the Flame and the Horsehead region. It's absolutely gorgeous, printed on sort of a metallic plate in beautiful color. And the image is interesting because he managed to remove the stars. And Alnitak is gone. And Alnitak is a very bright star, but he managed to remove the stars and just show all that nebulosity in the Horsehead and the Flame, and it makes a wonderful piece of art. So shout out to Carl Weber, a good friend who does a lot of astroimaging. Thank you, Carl.
Yes, and if we actually, the other night when we were sort of setting up for this and trying to get our ducks in a row for this live stream, Dave was actually able to share his screen with me, and then I was able to put it onto the live stream. But I'm certainly not going to try that this evening because it could be the one straw that breaks the camel's back here. I'm surprised actually that we're still running, to be perfectly honest, considering the problems that we were having earlier. My 5-year-old, who will be 6 in January, is a big fan of Orion, and she was very much like, "Daddy, Daddy, can I come out and join the beginning of the thing this evening?" But I was having so many problems that I had to say to my wife that, please take her in bed and take her to bed because I just can't cope with, another set of issues here. So she was a little upset with me, but I'll make it up to her tomorrow or something. We'll probably do a little bit more imaging if the weather is decent. Um, so again, I'm pretty pleased with that. That's not it's quite a nice image of the Flame Nebula there. Again, you can see this really distinct area of dark nebulosity that not only runs up the center here, but also these tributaries that run across. And this makes this a pretty spectacular image. And it kind of looks nice here with the Almatac just forming in the bottom image here. So again, I'm kind of quite pleased with that as an image. And then we are going to move on to one of the more difficult uh, images, albeit that um, the I got caught doing two things there. I shouldn't have done that. I was trying to read chat and speak at the same time, and my brain just crashed. Um, so Ross was saying, yes, 60-second subs are good, worth it for the deeper detail. Gary, is your daughter excited about the Jupiter Saturn conjunction? Uh, is it Monday night? And I'm glad you mentioned that, DJ, because Dave and I, in our Infinite Wisdom, are actually going to try and live stream the conjunction. Not that much is going to change over the short period of time that we're going to be able to see the conjunction of Saturn and Jupiter. And also, it's going to be a bit of a challenge because it's so low on the western horizon. But we will be doing a short 1 hour or so live stream, assuming, of course, that we don't have the technical problems that we've had this evening. I know several others are also planning to live stream the event as well. So if you get the opportunity on Monday, or I think it's the 21st, there would be a link on the SDAA website or our Facebook page for that. So if anybody wants to join, it would be great to have you there. I know that we're going to prepare a few slides on what conjunctions are and why this one's kind of special and so forth and so on. And in between those slides, we'll be showing well, basically real-time images of Saturn and Jupiter, and they will fit nicely in a half-inch or a half-degree field of view. Okay, right. So let me save this image because I want to keep a record of that. And we're going to move on to our next target, which is a Messier target. So let me just stop that. And this is going to be yeah, it's going to be M78. So let me just slew the scope. Again, we're not moving very far here. We're just slowly moving our way up we're kind of moving our way from the feet to the shoulders as we do this. And part of the reason that we're doing that is because the feet now are probably disappearing behind several high fir trees that I have in the garden here. I have an extremely limited field of view from my garden, and literally Orion will disappear at some point. So you can we can only be live streaming for so long because Orion will just not stay anywhere I can see it for very long. Right, so I am looping. I need to auto select a star. Okay. set my guiding going again. And I am going to go into here. This is M78. And again, I'm going to run this at a 60-second exposure. And this is actually one of the more difficult targets in the Orion constellation, even though it's a Messier object. I've not been really getting fantastic images of it so far, so it'll be interesting to see how it comes out this evening. So while we're waiting for that first image to form, I will just say that M78, and again, this is in the words of Burnham, is a bright diffuse nebula located about 2.3 degrees northeast from Zeta Orionis and virtually on the celestial equator. It was discovered in 1780 by P. McCain, who described it as two fairly bright nuclei surrounded by nebulosity. Messier, who observed it later in the same year, thought it to be a cluster of stars with much nebulosity. Admiral Smythe saw two stars in a very wispy nebula in which Lord Rosse thought to find some indication of spiral structure. And so these were the early, some of those names there are some of the well-known and famous astronomers of the late 1800s. Of course, we're all doing visual astronomy and sketched what they saw and often used quite colorful language to describe it. So M78 is one of the brightest portions of the vast nebulosity that covers much of Orion and which becomes visible in the presence of hot early type stars. Easily located with small telescopes, this object shows very little detail to the visual observer. The two bright stars enclosed within the cloud are about 53 arc seconds apart, and the nebulosity itself rather sharply bordered on the northwest side, melting away into the sky background towards the southeast. For a space of about half a degree around the nebula, the sky is heavily obscured by an absorbing cloud, which in which scarcely a star shows. And I believe we will see that. So here is M78, and here we can see the two stars that we talked about a few seconds ago, and I think also you can see this region here, which is the dark obscuring area that we also mentioned, and then further away we have another area of nebulosity in this area, and this kind of, I guess, a little bit reminiscent, Dave, of is it the Cocoon Nebula that also has the nebula kind of shows up in the middle, and then there's a very distinct donut of dark nebula that surrounds it?
I'm not sure, but this one is great because that it's a really great example of that dark nebula obscuring the outer portion. It's kind of nice.
Yes, yeah. And actually, this image is forming reasonably well. So let me just do a few adjustments here. And, you know, for those of you who are, I guess, perhaps looking for tips or stuff, I typically usually set my black level. I usually color balance, which you can do down here. There's a couple of auto color balance controls in SharpCap. I usually use the one on the left. As you can see, this is pretty much color balanced anyway. And then I usually set my back level, usually pretty much on the peak, and then, or just to the left of the peak, so perhaps over here somewhere. And then I use my mid-level point here to come in and sort of stretch. And interestingly enough there, if I stretch um, far enough, you can, I just saw my dust bunny appear back up here again. So I've obviously got to go into this optical chain and figure out where that is. But let me take that down a little bit. There we go. It only really shows up when it's really, the image is pretty heavily stretched. But usually that's kind of about the position. If you look at the sort of histogram. Now I know, I'm not sure if Mike is still on board, but I know he likes to be over here more, perhaps where we get perhaps a little bit more grey in the image. I tend to prefer a darker background, but it's it's very much a personal preference thing. So play around with it to your heart's content. There are also you can also do some additional um, display stretch here on this histogram, but I tend to leave this one alone most of the time, doing most of my work in the primary histogram. So again, we're that image is forming quite nicely. We've taken about 5 minutes worth of images already. I think this dark area, well, it's certainly very visible here. I mean, you can see there's a really sharp and relatively hard transition of this sweeping dark area going through here. And that I think is probably the best image. I shot this last night, and the seeing was obviously considerably worse last night because one, my guiding was considerably less stable, but I wasn't seeing this level of detail last night. So
Comment about from Burnham's book regarding magnitudes in this object.
sure.
Earlier, we were talking about the magnitudes of stars. High numbers means it's dim. Low numbers mean it's bright. And in Burnham's book, it says that these two brighter stars are listed as B-type giants with absolute magnitudes of about minus 1.5. So minus 1.5 is reasonably bright, but I need to explain something. He used the term absolute magnitude, and absolute magnitude is not what we see. What we see is visual magnitude, and if we saw a visual magnitude minus 1.5, that would be something as bright as Venus or something like that, very, very bright. So absolute magnitude means how much light is this object actually putting out. If we were right next to that star, how would we measure its magnitude? That's the absolute magnitude. Visual magnitude is what we see here on Earth. So if these stars are a long ways away, an absolute magnitude of minus 1.5 is probably going to translate to a visual magnitude of maybe 6 or 7. So keep that in mind when you're hearing the term magnitude of stars. Are we talking the absolute magnitude, how much light is generating, or are we talking about its visual magnitude, how bright does it look?
Okay, cool. Yes, and often with astronomy, there are multiple ways of describing things, and that's another example. But yeah, and it's kind of interesting to me, Dave, how this, um, I guess, became a Messier object. I mean, it's nowhere near as spectacular as many Messier objects, although I guess size-wise, it is certainly comparable with many of the globular clusters and everything you see. So perhaps that's the reason.
The other thing too is it was discovered by Pierre Méchain, and Pierre Méchain, of course, was Messier's sidekick, and Messier then observes it later on and ends up in his list. I suspect that there was maybe some competition between Messier and Méchain regarding finding and naming these objects. It's sort of an interesting dynamic that appears to go on there.
Yes, yeah, maybe that's the reason that this particular object did find its way into the Messier catalog. And just to illustrate how many things have gone wrong this evening, I was wondering why you may have seen from the interview type thing we did earlier on that I'm kind of sitting in a tent here, and the reason I'm sitting in a tent here is because I have a fan heater, which I think is called a space heater or something like that over here, but basically, something that blows hot air. And I wondered why I was getting cold because normally I'm quite warm in my tent here, and I had it blowing. I had it blowing, but unfortunately I forgot to actually switch the heater part on, which really has just been, kind of typical of how this whole evening's gone, really. But at least we are still going and doing okay. So I think we're almost coming to the end. I've got one or two more targets, I think, in the observing list here. I'm going to save this one. I'm not sure that NGC. Let me go and see what NGC. I've kind of forgotten what it is. NGC 2169. Okay. Okay, is that the last of my objects? So, yes. So NGC 2169 may not be the most spectacular of targets, but it is in my observation list for this evening. So we'll just quickly take a look at that. I think this will probably be the final image that we do in the constellation this evening, unless anybody's got any shout out requests. But I think we've covered most of the main area. The one thing that we haven't imaged this evening, um, my PC's just gone crazy. Oh, oh, good. Well, that worked out. The timing on that worked out spectacularly well because apparently I just got a message that came up on the screen to tell me my telescope has just disconnected again. Hold on. Let me. I don't. Let me. What? How it happened?
Well, at least it disconnected around 10 o'clock. So
Yeah.
that's fortunate.
Yeah. I think I've lost my. Yeah, I seem to have lost my scope. So maybe this is the place to finish. So before we close down the stream, let me try something. I'm going to try and bring us back into the interview mode format, just for my edification, rather than necessarily anybody else's who's on the. Uh, Here we go. Let's transition across to that. Okay. Dave, say something.
I'm here.
Okay, so yeah, there's the problem showing up. I appear to have two lots of audio. I'm wondering whether you've got an audio. Anyway, we won't worry about it too much. There's something to investigate, but I do seem to have two lots of audio, but it's not too bad. So hopefully everybody's had a fun evening. It's definitely gone a little better than I anticipated. As we struggled to get all the kit up and running. As I said, if you didn't hear at the beginning of the stream, I'm actually located in one physical location. Dave's located in another physical location. He's Skyping into me. I'm sending a screen share back to him so that he can see my real-time view. All because we're trying to get around the COVID restrictions here in Southern California. But it's been fun. It's definitely been a learning exercise for us again as we try and take our outreach program, and optimize it for online viewing. And look out for us again on the 21st when we'll be looking at the conjunction. Um, I hope you've had a fun evening. I will hand it over to Dave for just a few final thoughts from his end, and then I'll kind of wrap up with my transition slide just to take us out.
I think that I'm hoping that whoever is still out there has found this whole process somewhat entertaining. We really enjoy doing something which is as close to being live and hands-on as we can possibly get with the given restrictions. So it would be much, much easier for Gary and I to produce an entire show and record it and then post it up on YouTube and send a link to you so you can see it. But it would not have the same impact as knowing that you're actually there participating with all of these weird technology problems and these challenges that we have. It just makes me feel like I'm a little bit closer to the actual hands-on eyepiece in the scope, talking to the kids, stepping up on the ladder kind of outreach, which we have been doing for so many years with the San Diego Astronomy Association. So, I hope that you feel that this is entertaining and that it's at least somewhat informative. I certainly welcome any comments from anyone out there regarding problems you've noticed or things you would like to see. You can reach me at outreach@sdaa.org. There's a link on the website. You go to our website, and on the left-hand side, you'll find the links for all of the major officers, including myself, under the outreach program. So let us know what you think, and I hope you've enjoyed the evening. Gary and I were a little frustrated at about 7:45 tonight when things were not going well, but now that it's after 10 o'clock, I've had a wonderful time myself. And Gary, thank you so much for some very, very great images that we've been able to put together with this cobbled together system. So thanks again, Gary, for that work. And we thank all of you out there for participating, and keep an eye on our website and our calendars. We hope to continue doing a few more of these, and hopefully we will get better as we go along. So thank you very much. And Gary, back to you.
Yeah, and just to, sort of amplify one point that Dave made about what we're doing now in outreach and where we were. In 2019, I think it would be fair to say, Dave, that the club itself did probably 120 outreach events to school children, public, mainly at county parks and stuff like that. Would that be about the right number?
Yes. Every year we were doing 100 to 120 events, and reaching anywhere from 10 to 15,000 people. And that was all hands-on, people looking through our telescopes. And we have so many great members who supported this outreach program for all those years. And most of those members now have been frustrated because they can't continue. But we enjoy sharing the sky with those who are interested. The children are great. They're fascinated with the equipment. They're fascinated with the sky. And we just look for those opportunities where some young person or old person gets excited and begins to ask very interesting questions. So we will be back there as soon as circumstances allow us to do that. But I'm fairly certain that this electronically assisted astronomy will continue to be a major part of what San Diego outreach will be. So, glad to see you aboard, and that's where we're coming from.
Cool. Okay, Dave, great. And so I will just say goodbye to everybody. As Dave mentioned, we have a web page. We're also on Facebook. Just search for San Diego Astronomy Association. And obviously, this video has been hosted on the San Diego Astronomy Association YouTube channel. I have my own personal YouTube channel as well, where you can find a whole series of EAA events there as well. But it's been a fun evening. Thanks so much for everybody joining us. I really appreciate the fact that, well, I know some of you guys it's quite late for, in Ross's case, particularly early in the morning. So hopefully you've got a cup of coffee brewing there, Ross. And we'll look forward to the next live stream and hopefully catching up with you on the 21st, which is when we're planning to try the conjunction of Saturn and Jupiter. So good evening from Scripps Ranch. What was that?
If we can find a location.
Well, if we can find a location, and assuming we don't have clouds. But yes. So anyway, good night, everybody, and look forward to catching up with you again. And bye from both of us. Night.
Yep.